Sorry guys, it's been a rough weekend. I was kind of busy on the weekend. We're gonna be praying soon. That's okay. Logistics. On the backboard, we have a forever quiz tomorrow of all the cards since the last one, right? The last one, didn't we go through forever card number 11, the one that's currently up?
Yes.
So we have 12 through, what was the E to the X, B to the X one yesterday? Is that forever card number 16?
Yes.
Was it 15 on the video, which means it's 16 for us?
Yeah. Oh, that makes sense.
Does that make sense? I put a little note in Google Classroom. I was like, remember the forever cards. It's one.
Well, I checked the cover card.
It's okay.
It's only up to
Okay,
11.
that's all right. I'll have them all nice and updated. If you went in order, you're okay. I think the last one yesterday was forever card 16. So your cards 11 through 16 is what the quiz is on. Where did bonuses come from on forever quizzes?
Previous cards.
Previous cards
Oh,
and
updated.
or having it updated in class that day. So it's best to peek at the previous cards and have them updated in class, and that way hopefully you have all the chances to get a 20% bonus. Go team. But what's the other thing that's due tomorrow? The review from the book, right? I think both the chapter review and the practice test bonus are both posted online. Since I was gone yesterday, I apologize I didn't get the practice test copied off. I had to leave school early on, not early, but early for me on Friday. And I had a college physics kid come in and ask me a question on three-dimensional vectors, so I got a little distracted. Sorry for those of you who were trying to ask me things Friday, but I wasn't paying attention. But long story short, I will get you the copies of the practice test for tomorrow, but if you want, you can definitely print it off from the assignments. I think I attached a PDF of it, right? I think so. I think I did. I'll double check and make sure it's posted in case you guys want it earlier. I'll try to have it copied off in my room by the end of the day if you want the practice test. But first priority is the review from your book. Sound good? Okay. To that end, let's go ahead and pray quickly because we have a test coming on Thursday with the forever quiz and a workday-ish tomorrow. But let's pray first for our week because in calculus it's busy and student body events it's busy. Picking up with the video last year, there were a couple pages that kind of got left off, but basically it was just practicing the easier of the rules. This isn't the forever card. Remember, the forever card is all the logarithm ones. But these were the basics. Let's see how you guys did. Because the first one, wasn't it just constant multiple? Because all we have to do is say, well, the 5 can chill, and the ln has a way of deriving, a basic rule for deriving. So you should have gotten at the end just 5 over x. Or 5 times 1 over x, which becomes 5 over 1 times 1 over x. 5 over x. Number 2 is pretty basic too, except instead of just being 1 over x, it's going to be 1 over
3x.
Yeah, 1 over, well, that's the end, right, John? 1 over u. Hold on, how'd you get that 3x? Well, didn't you multiply by u prime? What's u prime? Because I have an outer and I have an inner, so my ln says 1 over. I'm like, sweet, 1 over, keep it the same, and then times u prime. So then, let's see, my x squared can reduce with my x cubed because that's over 1, right? And my 9 can reduce with my 3. Oh, it should end up being 3 over x. You guys agree with that?
Yeah.
Sweet. 1 over u times u prime. That would be, careful, who is that? That's our dy dx. Oh. Number 3. What additional rule did you have to consider besides logarithms and besides chain rule? Right? So you guys, what do you want to do? Actually, let me do words. I think on Friday I did the math and you did the words. Let me do the words and you do the math. Ready? So when the product rule says second, what should you have done? Oh, come on, more than Adam knew how to do this. You guys have been tons of times. Second, Adam, but good job. D first. 2x. What's next? Plus first.
X.
D second.
1 over 5.
1 over 5x plus 1 times
5.
U prime. Now, have you guys noticed that 1 over u times u prime, to some degree, depending on the u prime, could possibly be easily remembered as u prime over u? Now, that doesn't mean you have to use that every time. And sometimes the u prime is so complicated you do not want him in a numerator. You'd rather him just off to the side. So I don't necessarily want this in your forever card per se as like, oh, hey, u prime always over u. No. Remember 1 over x, remember 1 over u times, it's chain rule. No big deal. Times, unlock the inside u prime. But sometimes, if it's basic like this one, 1 over 5x plus 1 times 5 is just 5 over 5x plus 1. Now, warning, my kitten killers, not that you actually are, but you have a tendency to want to do so. What should you not cross out right now? Oh, okay, yeah, definitely not an x. I was thinking don't cross out a 5. A lot of kids would tend to be like, yay!
Or 5x plus 1.
Or a 5x plus, which is so horrible in so many ways, but it's illegal anyway because it's ln of, like, what's left? Ln, like, So rewriting, there's not a lot you could do. Why am I getting out my green pen? What is in common? It's very small, but what is in common? Yeah, just an x. That's it. That's the only thing in common. So we could have pulled out an x, and we would have had 2 ln of 5x plus 1 plus 5x all over 5x plus 1. Kitten killers beware. No. It needs to stay. But there is one thing that they could do, and which you guys know why. Why could this be the final answer? What changed? It's the property of logarithms. It's pre-cal. If you have a number in front, it can become a power. And in your homework, you might have had some problems where you derived it right, but they rewrote with some of those pre-cal problems. It's one of those make it match things. So if this answer's there, you're good. Just go for it. But I'm just warning you, if you see something weird, it's not all that pre-cal. Does that make sense? So it's one of those you could write in a color pen. Warning, pre-cal property at play, something like that. But number 4, not a product rule. It's a matryoshka, yeah. It's a within and within. It's an F and a G and an H. It's a, where is my little matryoshka? There it is. I mean, it's a she. I should call it. For some reason, I just call all inanimate objects. Because who's the outer? Yeah. No, it's a squid. Oh, there's no squid. Don't worry about that. Tan. Okay. But who's? Oh wait, pause. If tan's the outside, don't we always derive the outer first? Okay. So dy dx. Ooh, do you have this one memorized yet? What's the derivative of tan? Of who?
Sine of.
No. Of who? Yeah. Keep it the same, right? Right? But it's great.
Oh.
Because
sorry.
we keep it inside.
That was like sine. I'm sorry. I thought.
Oh. So you had the right idea. It just says ln. Got it. Okay. Times. As soon as I times, what do? Open. Hey, who's next? There's your
ln.
Okay, so ln.
Wait, no.
How do you derive an ln? 1 over. 1 over. Keep it the same. Remember who's inside? Oh, keep it inside. Times. Now what am I allowed to do? Peel off. What's the derivative of? Who's the last guy? Remember, think of that as x to the 1/2. True? That's just rewriting. Bring down the 1/2, negative 1/2 power, and negative pops it in the denominator. The 1/2 makes it a square root. Maybe you guys are starting to kind of memorize this one because we see it from time to time, right? Did we get our matryoshkas? Yes, indeed. Legally. How do we rewrite it? Yeah. You just kind of think of who's on the top and who's on the bottom. So we have secant of ln of square root of x all over 2x. Because the square root squared reduces. But yep. My dangerous ones with kitten killer tendencies, you cannot reduce anything else. Because if you took someone else, either the len is by himself or the sec is by himself, and either way it's weird. Alright, but what rules were we practicing on this page?
ln.
Dang, everything though, didn't we? We practiced the power rule, we practiced trig rules, we practiced ln, we practiced product rule, we practiced chain rules. We practiced ln rules, but what didn't we practice?
Exponential.
Yeah, how about all the other stuff? Well, first of all, aren't there things besides ln's? There are logs. Now wait, ln's are logs. They're log-based e's. But we have log-based anything else. Now technically the other page that you didn't get the other day, aka yesterday, was where the rule came from. But to be honest, if you like pre-cal, you will care, and if you don't like pre-cal, you will not care. We can change the base. You can write it down, or you can just pay attention and then ignore it later. We could technically change the base of log base b of x to be ln of x over ln of b. Why does that make a difference? If we are supposed to be deriving this guy, we could derive his rewritten form, which you might be like, that doesn't help anything. Well, I mean, most of us would think quotient rule, right?
Yes.
And when we do quotient rule, we would say, okay, dy dx for this guy would be bottom d top minus top d bottom b is a constant. Oh, so ln of b, if b is a 2, ln of 2, log base 2. If b is a 3, log base 3. It'd be ln of 3. Aren't those things I could put in my calculator and get a decimal for?
Mm-hmm.
That's a constant. And since that's a constant, what's the derivative of any constant?
0.
Oh, that just goes away. All over bottom
T top.
squared.
Top.
Bottom d top minus top d bottom. 0 all over bottom squared. Why am I allowed to reduce?
Subtraction went away.
Subtraction went away. And then I'm able to whoosh, whoosh, and then I end up with, well, most of you, I don't know, you're so good at
1 over x.
complex fractions, but yeah, it ends up being,
Oh, that's where it came from.
so technically you could just not memorize that rule and know that that's the change of base every time, but, oh wait, is there an easier way of thinking about this if that's a constant? Couldn't we also have just rewritten this?
The base.
Couldn't we have rewritten this as 1 over ln of b? Because if it's ln of x over 2 or ln of x over 3, it could be 1/2 or 1/3. I could do 1 over constant times, it's a constant multiple rule. What? And constant multiple rule says, oh, hey, just leave the constant and then take the derivative. It's the same thing. But did you guys notice that these rules are very, very similar? Too far. Because what's the derivative of ln of x? 1 over x. What's the derivative of ln of u? 1 over u times u prime. What's the derivative of log base b if x is in u's? Still 1 over x. Still 1 over u times u prime. But what's the extra little dude? Just this extra little constant.
Extra.
And to be honest, if you wanted just to memorize one rule for the whole page, you would go for this one. Do you know why? For the whole page. What are ln's again? Log base e's. Oh, log base e. I could do 1 over u times ln of e times u prime. But what would ln of e be? Oh. So these come from these. But either way.
From those?
Careful using the word derived. I know it's an English word, but in math it just gets complicated. So we'll say they are found. No, right? Well, I totally say derived all the time and then I get in trouble. So I'm like, wait, it has a mathematical meaning. Okay. Boop, boop. Yesterday, you guys saw this is a forever card, but you also saw more. Now, the rest of it you got in the video yesterday. And the video yesterday, I believe, would have looked something like, I don't remember, this?
Yes.
So if you guys didn't do that. There we go. And you did examples, and you did more examples, and then you did logarithmic differentiation, splitting up stuff, and then you did, we don't know how to do that yet. That's chapter 2B, or not to be. Then we reviewed exponential functions a little bit, And then hopefully you got to your last forever card, which is not forever 15 for you guys. It's forever 16. True? So let me steal this guy all the way down to this guy for your notes. Oh, that's not you guys. Oh, Santa.
That's Chapman. I'm good.
Wait for it. Good. So anybody who was gone yesterday, Abby, that was you, right?
I was gone, yes.
I tried to post the video that I had them watch. The only problem is it's a duplicate of the one from last year. So then it was like, what are you doing? You're crazy. I won't let you. And it was very sad.
And I couldn't find it.
I know. I'm sorry. It's technically, if you want to write it down. It's October.
Ew.
You know what, Andre? That was weird.
Where's that?
I think it's October 8th. October 8th, 2018. But it's the nice thing is, it starts with the log card, like the derivatives of all the LNs. Yeah. I think it's October 8th, 2018. Alright, cool kids. I'll go ahead and post a comment in all your Google Classrooms as to what the videos were so you could go back and find them. That's the one thing I should have done. Alright, here we go. Section 2.4B grade. Section 2.4B grade. You guys notice all the homework problems were from the end because it was section 2.4B.
Whoa, really?
Here we go. Let's zoom in.
Wow.
We're going to go fast. If you guys don't need homework questions, at some point, if you finish grading, you want to come up and grab an extra book to start working on your review, you may. You can access your Google Classroom in order to see that review. You guys see that L and a B for the exponential dude?
Wait, for number 162, why is there a 3 on the outside of GX squared?
Because to take the derivative of any matryoshka, I start on the outside to derive, keeping the inside, and then times inside prime. So the outside was a cube, so I bring down 3u squared times u prime. See it?
Hold on. I got it. Right here.
Remember 184? It's a little bit nasty because it's not letting me scroll. It's just stating your domain restriction. So with this new guy, yeah, to go look at the derivative rule for the absolute value of the right? We need to add that one into our forevers. But basically, it won't be on the quiz now. For the absolute value of something, it had you go look to find the rule, and one way of taking the derivative of an absolute value without writing it as a piecewise and taking the derivative piece by piece is to use the formula of u over absolute value of u, but as soon as you put an over, there's a domain restriction. So they're saying whenever this is 0, well, sign will always be 0 at any of the pi's. So it's just kind of saying where it won't exist. And where it won't exist, they're all going to be little baby shark points. That's why the derivative won't exist there. Can I scroll down?
Cool.
Remember, we'll have time for questions. Oh, never mind. That was the last even. You silly goose. Okay, I want to go over homework questions in just a second. I have the homework open and ready to go look at. But first, for those of you that are like, psh, I can totally start on my review. I want to get 15, 20 minutes of work done because I have a busy night tonight. All right, in Google Classroom, let's check what is online for you in preparation to Chapter 2A test. So, the first thing that is due tomorrow is the test review. Remember, due on Thursday is the practice test, and you're not turning the practice test into me, even though you'll get it as a handout. You're submitting pictures. But first of all, the test review. Bloop, bloop. There we go. Why do I give you an answer key to the test review? Yeah, I want you to know by tomorrow what you did or didn't get. Does that make sense, cool kids? Okay, so since I want you to know by tomorrow what you can or cannot get, remember, tomorrow or when you submit this on Google Classroom, you're not just trying it, you're also perfect. And I think I took off points last time if it wasn't graded. You have to read the directions. Reviews are different. Try it and grade it. Doesn't need to be corrected. You can bring in questions. Like, you don't have to have figured everything out in colored pen, but you do have to have it graded. So come grab a book if you're like, yeah, I think I'm good on homework. I'm ready to go. But the other thing that's in your Google Classroom is the bonus. And I believe, haha, not only do I have the answer key at the end, ignore all the ones with crossed out, but I also have the blank one at the beginning. So if you do want to start that tonight, just because you're like, I'm not going to Mr. HCS, I'll just do calculus all night. Lame. Or you'll do it while, don't do that.
While waiting in line for a good
Oh, there you go, there you go. Or it doesn't start till 7, so maybe you're going to go Starbucks it up for a bit, do your calculus, then come back. Anyway. There you go. Alright, guys. I am ready to go over any homework questions that you have from section 2.4. We do have one more book up here available, and we have people who are open to the homework that would probably be okay with you taking pictures of the pages. Some of you might want to take pictures of the pages. Or you just have a book. Okay, anything that we need to look at for homework 2.4?
127.
127. Kathleen, same one? 151. Wyatt? Perfect. 127, 151. Anything else? Rico? 166. Last call. All right. Remember, 127 starts us off with, he's right over here, horizontal tangent. Hey guys, is there a forever card from the last forever quiz about tangent lines? Yes, there is. Tangent lines. Remember, tangent lines have a slope that is the derivative. True? But when they say not just tangent line, but horizontal tangent line, horizontal means the slope is 0. True? So another way of saying this is find where the slope of the tangent line is 0, and the slope of the tangent line is the same thing as the derivative. So another way of rewording this question is find where, what's it called? F prime of x equals 0, because that is when the slope of the tangent line is, well, I should say where the tangent line is horizontal, where the slope is 0. Okay, so I have to take a derivative, and a derivative is going to be, derivative of cosine is negative sine. Derivative of sine of 2x, which actually could be rewritten as 2 sine cosine, but that would be a product rule. Let's do chain rule. Derivative of the outside, keep the inside, times derivative of the inside. If I had a green pen, I would underline and say, hey, there's a 2 in common, which would give me cosine 2x minus sine of x. We set that equal to 0. This is a very pre-calish problem. Not this, not the derivative setting equal to 0, but this. Because last year we would have had to think about, wait a minute, there's a way of rewriting him in terms of him. And that one would be, hold on, cosine squared minus sine squared, cosine squared is 1 minus sine squared. 1 minus 2 sine squared. Oh, dang. Do you guys see the quadratic? So I would rewrite him by pulling out a negative, because I hate negatives with a leading coefficient whenever I'm factoring. Factoring! And then I end up with 2 sine squared plus sine of x minus 1 equals 0. I have a times c of negative 2, a middle of 1. I could do a 2 and a 1 to multiply, to add. We could do grouping, or we could use a really snazzy star trick that says whenever you have a leading coefficient, you just draw a little line on top and put that leading coefficient and reduce if you can. Don't reduce if you can't. And look at the top as x's of terms and the bottom as numbers of terms, which lets you kind of cheat and skip all the work and go to 2 sine of x minus 1 times sine of x plus 1. Or you could do like actual grouping, you would end up at this exact same place. They're not just x's this time, they're sine of x's, which is why we had to actually write the sine of x in 1, 2 sine of x minus 1. Anyway, long story short, it's whenever sine equals positive 1/2 when setting equal to 0, or negative 1 when setting equal to 0, which in between 0 and 2 pi, when does sine equal positive 1/2? Sine is a y value, that's going to be at a pi over 6, or a 5 pi over 6. That's when the opposites are 1/2. When is sine going to equal negative 1? At 3 pi over 2. And so I would get pi over 6, 5 pi over 6, 3 pi over 2. As my locations for my HTLs. Why was it nasty? Trig, double angle properties, factoring with trig, unit circle. Possible, just hard. Possible, just hard. Next one is number 151, which I believe is on the next page. Is it a motion one? No.
Oh yeah, I did that.
Oh, it's the loggy one. Hey guys, isn't this a log-based B? Of you? While you're still memorizing your log rules, it might be a good idea, whether or not you're actually writing it, although writing does help you memorize, to identify what rule you need and write it out first before you go tackling. Now, you might want to rewrite this to be log base 5 of x squared minus 1 to the 1/2 power. That might make life a little bit easier. Because you actually have 3 matryoshkas again. Log is the outer, 1/2 is the middle, x squared minus 1 is the inner. So if you're that kind of person where you like to write it all with u's and v's, which remember some BC kids are like, that's just the way that'll make sense. You would write this as log base 5 of u. U would equal v to the 1/2. V would equal x squared minus 1. It's as easy as y prime times u prime times v prime. What does that mean though? Well, actually doing it and plugging in to get back to x's, what that means is that you would end up with, well, y prime is a log. And logs have the property of 1 over 2, the whole shebang, 1 over u, x squared minus 1 with the square root. Hold on, times ln of my b, which is 5, times u prime. Okay, well that u prime is right here, u prime. Well, u prime would be 1 over 2, 1/2 v to the negative 1/2. Well, v is this dude, so negative 1/2. I could just throw in that name. Times, so I have my log rule, I have my u prime, and then I need my v prime to finish off. My v prime is just 2x. And the name of the game is get it all together. What I see is 2's that reduce, an x that is left completely alone in the numerator. And then in the denominator, I see a square root that's been squared and an ln of 5. Maybe you would put the ln of 5 at the end, or maybe at the beginning, but either way, he's totally separate from what's going on here. If it helps you as far as comprehension, you could put him down here. He's just a coefficient of constant. Kitten killers beware. Stop, you're done. Nothing else to do. There we go, 151. Is that good? People that were trying to make it match. And then my last one is number 166.
Just the other question.
Yeah.
For logistics tomorrow, are we turning in everything? Like Homer spirals?
No. That's going to be a test on Thursday. Which
That's not what we turn everything?
Yeah.
No
Yeah.
books.
Notebooks, homework spirals, but not practice tests because those pictures get submitted online and you just leave them in your notebook. Kathleen? Yeah. Oh, well, if it helps, if you're trying to do it with words, aka not with like the Y's, U's, V's, you would peel off the log and you would tackle this guy. But to tackle that guy, Kathleen, you want to think of them rewritten with the 1/2 power. So then U has his own U, which we call V. U has a V. So the outer, the next would be peel down or bring down the 1/2. So 1/2 to the negative 1/2. And then we do our V prime. So check it. 1/2, negative 1/2, put that square root in the denominator. And then we did times our or V prime. Does that make sense, Ken? So then number 166 is the last one, and this is harmonic motion, you dude. You guys might wonder why this showed up if it's supposed to be exponential and log. I was taking homework problems from the end of homework, which partially included, because it was just chain rule, guys. This entire section was chain rule. I just separated it because I like the logs and exponentials in their own little place. So sorry, I'm sure you kind of showed up. But displacement, that's kind of like position in our 3 big things of motion: position, velocity, acceleration. Position is like the displacement, it's the how far. And they ask for the position and the velocity when t equals pi over 8. And position, okay. Displacement from equilibrium of an object. So there's an object on the end of a spring. And then it gets pulled in some way. Its displacement starts and it's like a sine curve. So this is equilibrium, and then my y is how far away. Displacement from the equilibrium of an object. So all I need to do for this one is just what is, for position, what is y of pi over 8. And then velocity is what is dy dx, or y prime, when x equals pi over 8. So for position, you would have just plugged it up here and said, okay, well, my y would equal 1/3 times cosine of pi over 8 with 12. That'd be 2 and 3. So 3 pi over 2. Minus 1/4 times sine of 3 pi over 2. When you plug in pi of 8 to t and to t, 12 over 8 is 3 over 2. Which you'd have to use unit circle like it's a thing. Where cosine is 0, so forget that. Because of the 0. Sine is negative 1. Well, negative 1/4 times negative 1 is 1/4. That's my position. And they don't tell me feet or inches, so it's like 1. Oh, no, feet. I apologize. I missed it. And then velocity, I'm not plugging into y, I'm plugging into dy. Sorry, dt. Should have seen the time. So we just need to take a derivative. So derivative of cosine is negative sine of u. But the problem is I also have a u prime, and 12 over 3 makes a 4. And then derivative of sine is positive cosine, but there's a negative already. Cosine of 12t, but there's also a u prime. 12 over 4 is 3. So then we would need to plug into all of this our pi over 8, which means put him in each of your t spots. Once again, we have 12 over 8, which is 3 over 2, but now we have negative 4 sine of 3 pi over 2 minus 3 cosine of 3 pi over 2. Nice thing is, cosine of 3 pi over 2 is still just 0. Sine of 3 pi over 2 is now negative 1, and a negative 1 times a negative 4 is positive 4, but units is displacement, feet over time, seconds. Are we okay to stop for today? Okay. I'm going to put up the Google Classroom assignment if you guys haven't written it down. We don't have tons of time, so maybe just writing it down and getting a picture of someone who's open to the homework might help you work on it at some point today if you grab or you have a little bit of extra time in and amongst all of your different responsibilities. So, test review, yeah. It's due tomorrow, attempted and graded. Come with questions. So our workday can be with questions. However, you don't have to write directions, you don't have to write problem details. I know some of you have really crazy busy nights tonight, so here's the deal. If you if you are involved in some way, shape, or form with Mr. HCS, you have extra responsibilities above and beyond those who are going to come and sit and watch for an hour. So if you submit this by the due date of the bonus test, aka by the test day, which I don't recommend you doing this the morning of the test. I think that's kind of foolish, but I will give you an extra day. Just post in the comment, Mr. HCS. Sound good? Sound good? Because the practice test is optional, so technically I just try to have you do the review so that we can go over questions. So if you are a contestant, if you are an organizer, you may go ahead and post Mr. HCS and turn it in up to a day late.